Very good evening to all respected members who have gathered here for the subsequent research lecture series under latest research trends in mechanical engineering. So now we are going to see about design for manufacturing and assembly. So here in this topic, we are going to discuss about what are all the various the focus area to be strongly discussed in the product design fundamentals as well as product manufacturing part, and what are the various outcomes from the technology point of view by implementing CAD and CAM. So we are going to see everything as a form of nutshell. We will get into the session objectives. So these are our session objectives for today's topic of presentation. So design for manufacturing and assembly. So here the research objectives primarily focus on optimizing standard product design by minimizing the production cost, reducing the number of the part count by simplifying the assembly time, and enhance the final product quality by simplifying the manufacturing process. The following are some of the key objectives that are highlighted here: reducing the number of part count in both manufacturing as well as the assembly process, streamlining the assembly by simplifying the number of part count, enhancing the reliability as well as uh, increasing the quality of the product design such that we can able to plan and execute the manufacturing task on time, so final product can be launched quickly on time to the market, and also encouraging lot of sustainable practices subject to environment. Accordingly, the materials and process will be selected according to the sustainable environmental goals. So these are some of the session objectives that are listed out here. So in connection to the session objectives, now we will move on to the problem statement directly. So design for manufacturing and assembly mainly focus on optimizing the product design for better, easier fabrication and assembly. So by doing so, we can able to simplify most of the design and manufacturing attributes by reducing the cost. Uh, Thereby, we can minimize the number of part count, and quickly we can speed up all the production process by launching the product quickly on time to the market. So following are some of the various key areas include, say, modularization, standardized design modular concept, adapting standardized threaded fasteners, and utilizing automated assembly techniques, particularly in automotive, aerospace, and construction sectors. So this is about the problem background of design for manufacturing and assembly. Let us discuss the common core areas for research. First, let us consider methodology and principles. So the mainly research focus on reducing the total number of component assembly. So that will improve the assembly efficiency, and also while implementing the design principles, say symmetrical geometry and easy self-locating parts. So these are the core theme of design for manufacturing and assembly. Next one is cost reduction and optimization. Apply method, say design to cost approach. So based on that, so we can able to conduct a thorough investigative analysis how design for assembly concept can be benefited for both assembly as well as the manufacturing process. Here are some of the sector-specific applications are listed out. First, let us go with the construction assembly process. So here the research is heavily focused on prefabrication, most ready-made modular structural design, and cross-laminated timber systems. Next is automotive application. So the studies mainly focus on reducing the assembly time for components, say like door modules during the process of assembly. Then next, design for automation, developing, analyzing, and producing the standard optimized parts for robot assembly. Say using direct press fit or snap fit, we can able to reduce the number of screws or threaded fasteners joints. Integration with the technology. So researching the use of product data management system, we can adequately select the materials used for manufacturing process. Thereby we can perform the cost estimation, which manufacturing process is considered to be relatively cheap and lesser amount. So this can be done with the help of the DFMA software with the interface of product data management system. Now let us discuss a small case study on DFMA concept, design and analysis of modular fixture for a mission wise. So in this case study, so both CAD as well as the CAM, the computer aided manufacturing concepts, both were addressed very clearly. So normally due to the technological modernization, a lot of advancement came in the area of fixture design and assembly. So in this work, an attempt has been made to design and analyze the modern screwless machine wise with the help of CATIA and ANSI software package. So mainly these tools are used to find out the drawbacks of existing machine wise by proposing a new revised change in design. Let us see the further continuation in the next slide. So in the existing system of machine wise, the most common problem is the lead screw. So due to aging effect, the poor maintenance characteristics, sometimes the lead screw may tend to undergo mechanical wear and tear. So as a result, the movable jaw of machine wise may lose its contact or grip to hold the work component very rigidly. So in order to overcome such type of problem, a dual pin type of movable jaw was designed in such a way in order to incorporate into the base block of the movable jaw. Here I am presenting the design for your kind reference, both existing design of the screwless machine wise and the new proposed design of screwless machine wise. So here the comparison is relative comparison, merit, disadvantage, everything is given here in this slide. So based on this, what are the inference from figure 1 and figure 2? So in the existing design, in the very old design as shown in the figure 1, it has certain technical demerits such as clamping force requires high holding capacity to tightly connect the jaw between the two gripping end. But here it is not highly sufficient enough to hold the jaw. Since the movement of the movable jaw was restricted due to the presence of triangular block inside the hollow groove support. So in order to overcome the drawbacks of existing machine wise, the proposed model of the screwless machine wise was suggested, and that is shown in figure number 2. So as per figure number 2, so this is considered to be more relatively simple, easier in design as compared to the previous one. So in this type of attempt, uh, so we can consider the modular fixture as considered to be more flexible in nature, and the modular fixture itself considered as a movable jaw provide with the ready-made Allen key slot setup, so that can further simplify the assembly process as prescribed in the as better compared to the previous model. Here from this figure you can able to see this is the movable jaw. This act as a modular fixture. So we can able to adjust according to the geometry of the work element. We can able to keep anywhere on the provided the hole slots very easily. So thereby this one is considered to be relatively simple, easy to understand as compared to the previous one. So what are the various future directions according to the design for manufacturing and assembly concept? Using AI and digital simulation. So AI tool will more support to simulate the assembly process by automatically optimizing the part geometry for easier manufacturing as well as assembly job operation. Next, using 3D printing. So we can consolidate the complex geometry into single lighter and stronger parts. Thereby we can reduce the need for the threaded fasteners. Then use of digital twins, create a virtual component of products to test the manufacturing feasibility as well as the assembly sequence before the final physical production. Then intelligent automation. By equipping the robots with advanced sensor mechanism, so we can handle complex small batch assembly tasks very easily as compared to the human labor. So what are all the overall benefits of using design for manufacturing and assembly concept for a new product development? We can able to save the cost and time, improve the quality of the design, and overall using sustainable energy management goals, environmental management goals, so we can able to reduce the material wastage and save the environment at the outset. Now we are in the final end of the presentation. So by embracing both design for manufacturing and design for assembly, so we can able to find out lot of significant improvement by cutting down the production cost, maximizing the product quality, and also bringing the product on time to the market. So at the same time, we can encourage faster collaboration between the suppliers in a more reliable manner so that we can bring out high competitive products across the globe. So in conclusion, I can say that adapting TFMA is not only merely a technical step to optimize the product design and manufacturing, and it is considered to be an overall strategic process to enhance the profitability as well as the product performance in a competitive market. So these are some of the reference work conducted in the past related to the case study material. So once again, I thank all the member participants, students from various engineering colleges, faculty members, and respected industry professionals from various reputed companies. Once again, I thank all the participants. We will meet in the next subsequent parallel lecture series under latest research trends in mechanical engineering. Thank you again.